Hi y'all, it's Sarah. Today we are continuing to talk about L'Hopital's rule, and we're going to specifically be talking about how to deal with indeterminate differences. So indeterminate differences are when our function is actually the difference of two functions, right? We're taking the limit of a difference of two functions, and when we take this limit, we get infinity minus infinity. So that's called an indeterminate difference. And so basically, our goal here is going to be to get this into a form that we can L'Hopital, right? So instead of being a difference, we want it to be a quotient, where when we take that limit, we get either 0 over 0 or infinity over infinity. So in order to do that, we need to combine the two functions that we're taking the difference of. So the first step is to find their common denominator. The next step is to use that common denominator to combine the two functions into one function that is a fraction. And then step 3, we're able to apply L'Hopital's rule as many times as we need to until our answer is not indeterminate. So our first example is going to be the limit as x approaches pi over 2 from the left of secant minus tangent. And so if we plug in pi over 2 from the left here, secant of pi over 2 from the left minus tangent of pi over 2 from the left, what we're going to get is infinity minus infinity. So this is our indeterminate difference, right? And so we're going to, before we can L'Hopital this, we need to rearrange it. So we're going to recognize that secant is actually just 1 over cosine. So we're going to rewrite it as 1 over cosine of x. And tangent is just sine over cosine. So we can rewrite it this way. So now they both have a common denominator of cosine. So I can rewrite this as the limit as x approaches pi over 2 from the left of 1 minus sine x over cosine of x. And now I just need to check that this actually gives us 0 over 0 or infinity over infinity. So 1 minus sine of pi over 2 from the left divided by cosine of pi over 2 from the left is going to be, that's going to be 1 minus 1 over 0, which is 0 over 0. So this is a form that we can L'Hopital. So we're going to apply L'Hopital's rule here. So the derivative of 1 is just 0. The derivative of sine is cosine, so the derivative of negative sine will be negative cosine. And then the derivative of cosine is negative sine. So we can go ahead and rewrite this. You could rewrite it as cotangent. I'm just going to keep it as, just going to cancel out the negative and just make it cosine over sine. When we plug in our pi over 2 here, we have cosine of pi over 2 from the left divided by sine of pi over 2 from the left. And when we think about what those values are, for cosine, that's going to give us 0. And then for sine, it's going to give us 1. So our answer is going to be 0. All right, for our next example, we have the limit as x approaches 0 from the right of the difference of these two fractions. And so what we're going to want to do here, in order to find a common denominator, we're going to multiply this first one by e to the x minus 1 over itself. And then we're going to multiply the second one by x over x. So we're going to have e to the x minus 1 over x times e to the x minus 1 minus x over x times e to the x minus 1. And so now what we can do is combine these into one fraction because they have the same denominator. So it'll be e to the x minus 1 minus x over x times e to the x minus 1. So when we plug in 0 from the right, we're going to have e to the 0 from the right minus 1 minus 0 from the right over 0 from the right times e to the 0 from the right minus 1. And e to the 0 power is just 1. So this becomes 1 minus 0 over 0 times 1 minus 1, which comes out to 0 over 0. So we're in a form that we can L'Hopital. So now we're going to L'Hopital this here. So derivative of e to the x is just e to the x. The negative 1 goes away, and the negative x becomes a negative 1. And then on the bottom, we have to use product rule, or we could just distribute out the x, but I'm just going to go ahead and do product rule. So we have e to the x minus 1 plus x times e to the x, and then the negative 1 goes away when we take the derivative. So to simplify this, we're going to have e to the x minus 1 over e to the x minus 1 plus x e to the x. All right. So now if we are to plug in 0, what we're going to get is e to the 0, which again, I'm just going to go ahead and write 1. So 1 minus 1 over 1 minus 1 plus 0. So again, this is going to be 0 over 0. So we L'Hopital again. So now the numerator will just become e to the x, and the denominator will become e to the x plus e to the x plus x e to the x. So we have the limit as x approaches 0 from the right of e to the x over 2 e to the x plus x e to the x. Now we plug in 0. We have e to the 0, which is 1. 2 times e to the 0. E to the 0 is 1, so that's just 2. Plus 0 times 1. So this just becomes 1/2, and that's our limit. All right, if you enjoyed this video, please like and subscribe, and I'll be back next time with some videos on different types of indeterminate forms.